All right, students, we are starting 5.1, okay? Simplifying radical expressions. So first things first, we have a few vocab here. This symbol right here in the little pocket of the radical sign, students, this is what we call the index, okay? So up until this point, we have seen a square root, which has an index of 2. We have seen cube root, which has an index of 3. So the indexes are the little tiny number that goes in the little pocket. Now, if it's a square root, we don't normally write a 2, but cube and fourth and fifth and so on, we will need to write those index numbers. Then this sign right here, we call this the radical sign, okay? Now the stuff that's inside, that's what we call the radicand, okay? So this radicand is x. So when I use these words, please do know where they are supposed to be. For this particular section, we cannot use a calculator, okay? So please do not use a calculator when you are working on your homework or your notes. Find the index. So examples 1, 2, and 3, all we are looking for are the indexes. Remember, the indexes are what's showing in the little pocket. In this case, guys, your index is 3. Okay, so number 1 index is 3. Now box that up because that's all they wanted to find. So go ahead and find the index for number 2 and index for number 3. Now remember, if you don't see one, then remember we read it as square root, and square root would have an index of 2. There are 2 ways, students, to simplify roots, okay, or these are called square roots, okay, cube roots, fourth roots. So these are called roots, okay. Method number 1 says, first, we are going to factor. Notice how factoring is so important, which means we are going to rewrite them using multiplication. Step number 2 says group equal numbers, okay, into group size of that index. So if it's square root, we would need 2 identical items to simplify. If it's cube root, we would need 3, and so on and so on. Rewrite them using exponents. And number 4, simplify anything you can, aka take it outside of the radical. And then number 5, anything that's left will be staying inside the radical sign. Now method number 2 is going to say factor using perfect squares. Okay, so if I say square root of 9, we should know that should be 3. Or if we say cube root of 64, guys, that's going to be 4. Okay. Step number 2, take the root. This should now be outside. Okay, whatever is left is going to be on the inside of the radical sign. So that's step number 3. So take a minute to copy these down. Okay, so remember, there are 2 ways to simplify these. Example number 4 said simplify square root of 50. Now, student, square root of 50, we know that there's 25 times 2. Now 25 is a perfect square number, so we can rewrite it as 25 times 2, which, students, we can break it up to 25, okay, under its own radical times square root of 2. Well, 25, student, is a perfect square number that can be simplified as 5, and then square root of 2 that cannot be simplified, so we are going to rewrite it as 5 times square root of 2. Remember, we cannot use a calculator, so if we can't go straight to 25 times 2, keep breaking that down. Number 5, students, said find the cube root of 108. Okay, so 108, I'm going to see if I can break it down, factor that down. First, I'm going to say, okay, well, 2 goes in there since it's an even number. Okay, now 108 divided by 2, we are going to see 54. Okay, well, 54 is an even number. We can break down to 2. Well, 2 goes into 54 is going to be 27 times. Well, I know 27 times is going to be a perfect cube. So I am now going to stop these right here, okay, and write it like this. So cube root, remember, that goes into that little hole right there in the little pocket. Then we're going to do 2 times 2 times 27. 27, cube root of that is going to be a perfect 3. So that goes on the outside. Then on the inside, remember, write the little index number in the little pocket and make sure it looks like it's in the little pocket. Well, 2 times 2 are the numbers that are left. then we have to simplify all the radicands, okay? So final answer is 3 times cube root of 4, and we are going to box that up. I'm going to do number 7 with you, and then leave number 6 for you to try, okay? All right, 7 said, hey, simplify 4th root of AD. So let's break AD down. AD is going to be 2 times 40. 40 is 2 times 20. 20 is 2 times 10. And 10 is 2 times 5. So these are all prime numbers. So we can rewrite it as 4th index. That low number goes right there. 2 times 2 times 2. Looks like we got 1, 2, 3, 4. 4 of them. And then there's a 5. Okay. Well, 4 identical numbers and an index of 4, we are definitely going to be able to take out a 2. And then what's left on the inside, students, it's 1, 5. Okay, so 1, 5, index of 4, that cannot be simplified. So we will leave it just like that. Next is going to be example 6, which I would like for you to do it on your own and then box up your final answer like that. So we always, students, want the positive root, known as the principal root, unless we're told otherwise. So let's check out example 8, 9, 10, 11, okay? So normally when we do a square root, like for example, square root 24 here in example 6, whatever the answer you have is what you have. Now this one says -1, this is the same thing, students, as -1 times square root of 64. Well, there's a negative in the front, so we know our answer will be negative. So square root of 64 is going to be 8. -1 times 8 is now a -8. In this case, because there's a negative in the front, we have to carry that -1 and multiply that to your simplifying root of 8. Now 9 is very similar. 9 said, hey, there are 2 answers, plus and minus already to begin with. So we are going to have both answers when we simplify this out. Now 81, square root of 81, it's 9 times 9, so that's going to be a perfect number. And n squared, students, is n times n. Since it is a square root, we don't see an index, so we are always going to know it's a square root. So this is going to say plus or minus 9n, okay? I'm going to box this up for now, and then we will talk about we will add other stuff later. Number 10, square root of x plus 1 to the 4th power. Okay, so let's talk about the 4th power. Well, we have an index of 2 since it's a square root, and there are 4 of these right here, guys. So what's going to happen is, I could write it out 4 times like this, but we know if it's a square root, every pairs, right? Every couple will get to be simplified out. So technically on the outside, there are 2 of these because we have 2 pairs, okay? With the square root, each pair, 1 will come out. But normally when we have 2 of them come out, we can just write it as a power of 2. So when we have an even index, okay, and a square root, we can just take that power of 4 divided by index, and that will give us a power of 2. Now we have a cube root now, students. So cube root is going to need 3 items, okay? So index of 3 goes here. 8, we know that's a perfect cube, but I'm just going to remind you why it is, because it's 2 times 2 times 2 is 8. N squared, y'all, is n times n. That will not be enough to simplify out. So the only thing that's going to go out of the radical sign is 2. So 2 times cube root of n squared. That stays right back inside. So your radicand is n squared. So here are all the things that are simplified.